Well, welcome. My name is John LaMaster. I teach at Indiana Purdue Fort Wayne. The full name is Indiana University Purdue University at Fort Wayne. And my students often come in. It's a heterogeneous classroom in every way because they can bring any technology in they want to. But what most likely we see are the 84s. And I actually use the 84 panel still in my classroom more than I use the Smart View because that's what we have. And so if I fumble a little with the Smart View, it's because it's just not what I usually do. Most of the time a student's hands are on the machine and I'm kind of navigating in the classroom. What is nice to know though is because the whole curriculum that I do is kind of working through 84s, I found that I was able to make some activities that really tie into the features of the 84 plus C that are enhanced, as well as if you have the 84 classroom without the color, they'll work in some ways. Some of these handouts will work, activities will work as well too. So I'm really thrilled to show you the 84C. You have one in front of you. What you'll notice immediately is that it has a backlight when you turn it on, and you can see that they're a lot lighter. So if I'm holding the 84 versus the 84C, this is heavier because there's 4 AAA batteries in here. There are no AAA batteries in here. And so you charge it by using a cable. And you want to use the correct cable. You already have that cable if you have this black unit to computer cable, this black link. And so that works. That's one way to charge it. And so the way to also charge it is if you were to have a charging bay. If you had a classroom set, there's some charging bays down on the floor. And I had a friend who forgot his cable or he couldn't find it, so he just picked up his cellular phone charger and stuck that in the calculator. I think you might want to be careful about what you stick in your machine, but it turned out that it worked. So you've got ways to plug it into the wall too. So that's important, and if you'll notice on the screen where you look up there on the status bar, there's a battery indicator. So I'm going to point to that on the screen. And it's full battery, of course, because we're using the emulator. But what's nice is when you pay attention to that and it goes all the way down, there's no backup battery in the calculator for you to recover something if your calculator went all the way out of batteries. So it's time to then just buck up and put it into the wall or put it into the computer if you're finding yourself low on batteries. What we're going to do today, the handout kind of gives some activities to address not just the title, what can this calculator do, but also the plug was they'll help you foster those mathematical practices of the Common Core State standards. And so we're going to see the fun activities that you can use to develop those practices. And along the way, we'll see the calculator too. So you get 2 for 1 in this session. So so I knew then you could take them home and you can even use them Monday on the 84 in some ways. So we'll first start off with investigation 1. And I assume that that's what your students would do as well, is they would say, simplifying rational functions, oh, what fun. Can I have more? You know, please, sir, I want some more. You know, and I don't know, maybe your students aren't like mine, but they would rather, you know, shovel manure than do that. So here are these 2 Common Core standards. If you look at the way you can do this with the table feature, it's a possibility to pitch this in a way that that actually I think can make this fun and meet those 2 standards. So the very first thing what I'd like to do is we'll get our calculators turned on, and I'd like you to do me a favor, reset defaults, because your calculators have been touched by others, and we want to make sure that they are purged. So we're going to go to second memory, and you'll see reset has 3 dots after it, which is actually comforting because that means there's more behind that door. It isn't, oops, if I'm really sure. So we can hit enter, and we want the defaults, not all RAM. So be careful, watch your caffeine indication if you pressed the wrong button. You want just the defaults. And then hit enter. And in case you hit enter extra times, you have to actually go down. And we'll set the defaults. So you'll get that cleaned out. I actually reset my RAM because I was following the mantra. Have you heard people use mantras like, oh, second mem 722, like it's a phone number? Well, I was doing that, but I hit second mem 712, and I was very sad because, it was last night. So there we go. And luckily, I backed up. But so I kind of just watch. I'm careful about that. Using mantras it sometimes gets me in trouble. And what I'd like to do is, with this investigation, we're going to set this machine up so that we can see this table. And just to kind of clarify how it would work in the classroom, is your students would just see this table. They wouldn't quite yet see the rational function yet. And that you would ask them, can you find what is the pattern? You notice I've changed the question now from a closed question to an open. What patterns do you see? And there's a lot more answers to that than just simply what's the next in the step. So we're going to look at that. So let's set that up as teachers now. We'd have to go to your y = menu. And we need that in there. So I'm going to make this screen larger so you can see it. And I really want to look like the stacked fractions in there. And we're going to see what will happen. And so I'm going to hit X. And how many of you have used the shortcut keys, shortcut menus? Not everybody in the room. So we're going to see that by pressing alpha. And then if you go to the y = menu, there you'll see some shortcuts right there, a shortcut menu. And we can get a stacked fraction at number 1. What's new about the calculator, you already have seen in your y = menu, there's some color on the side. But look at this, just right arrowing. You can see you couldn't do that before. So now you get the right arrow. We're going to use the first one. And we'll hit enter. And we need 1 over x. What I need next is the table set so that we're at 1 for the start and 1 at the change in table. And now you get the table. And this is where you'd ask your students to explore. So you display this table and say to your students, well, what patterns do you see? What's the next value? And I want you to also turn to your neighbor and explore what is different about the calculator that you didn't see on an 84 that's on this screen too. So we've got two fun things to talk to your neighbor about. So take just 1 minute and look at that. And I'm going to be listening in.
I have to tell you, for every 1 change in the denominator, apparently it's going up by odd numbers in the numerator. So
you've noticed something about the numerator.
9, 11.
Yeah.
Yeah, so for every 1 change in the denominator, the numerator goes up by odd numbers.
That's excellent. OK. May I have what you've just mentioned to us, and I'm going to revoice it. You said for every change in the denominator by 1, the numerator goes up by an n plus 1, so it's an odd number. So you looked at the numerators, and you said, oh, OK, that kind of breaks. Oh, I got a little more there showing. That if I see these numerators here, you are pretty easily finding the denominators, but these turned out to be going up by odd numbers. So what do you suggest the next?
Subtract those again, and they'll be put it by 2.
So we'll see this 13. So what's your next numerator, do you think? 50, yeah, OK. So did anyone have a different pattern that they noticed? Yes?
You can also square the numerator and then add 1.
OK, so if I look at the numerator, I'm going to get a new color here, that I can see that that is add 1 to a perfect square, and I can get, or subtract 1 off of the numerator, and I get perfect squares. Very nice. So you get the 49. In fact, that might be easier to see that this is going to be 65, right? OK. So all of that shows up. Now, what is also neat is let's look at what the calculators, what's different about the calculator. And we've got a couple of things to notice here. What have you noticed? Fractions are showing in both the cells right here, as well as you can see, did you look up there, press plus? There's some help up there. That's neat to see. And if you climb, I went and it said press enter to edit. If I went onto the highlighted the color numbers, there's some extra assistance there. They call that context help. And we call this the status bar. So you get some helping hand right there. And so the fractions show up in the cells, and they show up. Since it said press enter to edit, we could do that, or go up. We can actually see the expression. And in fact, if you show the expression to your students, you could now say, do you think this could help you with your pattern? Or let's verify the pattern, because you've got a conjecture. There's not all the comments yet about what else might be available on this. The line separators. The spacing has changed. We don't need a big space there for the 2, but they adjust the space for this. And also in the status bar, isn't it outstanding now that you can tell some of the mode settings that cause the most trouble? Have you had ever a student who was thinking they were in degrees, but they were in radians instead, and they had the wrong number, or vice versa? Or they had a setting accidentally. They blame it on gremlins, but they're out there. They accidentally rounded their number to an integer, and so square root of 2 turned out to be 1 today because of the new excitement of rounding. So that can. What is important is up there, so you can now get attuned to looking at that. All right, very nice. And also, of course, the color. So we can see a lot of stuff on there. What I'd like to do is next actually press the mode button. And here you go. You have been smart on that. I'm going to give you some candy there because you nailed the. Oh, who else was it who told me the perfect square? Yeah, there we go. And I'm getting better at throwing. I almost had you right in the hand. So here we have the mode button. And new things are on this button now, too, or on this menu as well. Let's enjoy this. What do you notice that's different? Math Print in Classic is now up at the top. That is one of my favorites. You get an everlasting gobstopper for that. All right, because I change often from Math Print to Classic, and now I just right up there. And it's handy for me. said many prayers of thanks for that. You know, that's just outstanding. I also heard thick dot, thick, thin, dot, thin. So different line styles now because of the higher resolution. What else have you noticed? What's that? More things. Believe it or not, on the old 84, which isn't really that old anymore, on the current 84, you have all of these things except the resolution change, and they're just on 2 pages. So this is a different color. I noticed that right off the bat, and I was wondering why. And so I came up with my own thought. But what do you think it might be? What do you think? Why might that be a different color?
It comes from math print instead of plastic. Most of those blue things are things that came up in the new math print.
The blue things are going to be for the when we made that math print operating system, they joined us from there. Yes, that's excellent. And so they're actually on the second page of the regular calculator. Oh, I was so good on the first 2. I'm going to work. You get a double one. All right. So
Actually, I think that blue is what the teachers ask for the most.
the blue is what the teachers ask for the most.
Diagnostics, you always want to have that on, and half the time it's not.
These are really friendly to help you out in classroom management. So I've heard a couple of thoughts of, well, they're both, they're on the second page. So they're, if you had a side-by-side classroom of 84s and 84Cs, you could tell them where they are. The other thing is, look at the functionality of them as well. You know, you've got here a bunch of highlighting to navigate with the arrow key to press enter. Here, these are sort of prompts to say, how do you want these settings? And so that's nice. That's for fun. Change this to, I'd like you to go all the way down to fraction type. And it's something that I would only show my students at the end of the activity. I'm going to hit enter and change it to from stacked fraction improper to mixed. So I'll do that. And now, what happens if you go back to your table? Isn't that revealing? And this is kind of a neat trick that I saw in an earlier session, that if you actually grab this and pull it onto your document, you can just take it right off of your Smart View right now and put it into anything you wish. And isn't that what we kind of thought would happen? You've got these kind of mixed numbers. What we've done is we've motivated the now the need for actually solving the simplifying this. And so if I put an x over an x to get a least common denominator, I have x squared plus 1 over x. That's what you kind of said here. Take a perfect square, add 1, and you get and divide it by the denominator. And also, what's kind of neat is these are just when you grab the a mixed number, you just take x times x, right, and add 1 to it. So you kind of see that, and you've definitely used the structure as well as repeated reasoning, all in one activity where you had to do this. We're already doing this when in the classroom. Now we can bring that kind of in. And we've seen that color shows up, and we've got a little bit extra fun with our table. I, like you, probably would want to see how do I change the color. So let's go there. We're going to go into the y equal menu just to show you that I can change. Oh, before, remember I was at second table. And if I were to go to y1 and hit enter, I can change the expression here, but I can't change the color. So the place to change the color is where we put it in at the beginning, which is here. And we'll go all the way to the left and hit enter. And that's where you also change the graph style on the 84. Here we have a choice, and we call this a spinner. So we have a spinner now that we can use to get any color you wish by hitting the right arrow keys and picking your favorite. I'll let you pick yours. I'll pick green. And line will be nice to pick the style. So I can go shade above, shade below. Animated path. Headless horseman right there with a head. Actually, horseless head. Is that what it is? All right, and dot and thin dot. So all of these line styles, thin and thick, kind of cycle through. So you can pick your favorite and hit OK. You have to hit OK. If you leave right now, suppose there was an emergency thunderstorm and everybody had to leave, or it wouldn't work, right? You have to hit OK and hit Enter to say, yes, please. Now it'll change the table. And if you press Graph, let's see where you might be. We might want to hit Zoom. Oh, we reset defaults so everybody would have the same window. We can just hit Graph and see there it is. And it made some dots where we wanted the graph. And so the dots kind of share the, were plastered on there. And we can trace on it as well. What's really fun, I noticed this last session, is somebody decided to change, went to Y2, and they put in x plus, and they decided 1 divided by x rather than 1 with the stacked fraction x. So we have kind of ways to look at this. That's the stacked fraction, and we call that sometimes the thin bar division. And here's a neat feature with that. Look what will happen when we hit second table set, or second table. You get a mix because you are on auto mode, where it will decide based on what you have asked it to do. I'll display it that way. So you can get both if you want and see the equivalence. And that was something that someone shared in the last session. It was worth to repeat. So we've got the graph. There's that. When we look at the window, you can see that there's some same features here, but you also get the context help. I'm curious, can someone share with me the X-res, what that might mean? Yeah, X resolution. So if I changed it to, say, 8, what do you expect to happen? It's going to graph a lot faster because it will have less. Ooh, that's interesting. And it graphed a really, both of those are at the same graph, right? I'm going to deselect this by hitting the Enter key just to graph one at a time. That's the graph of this. And the TI calculator will connect those with line segments. So you've got the line segments now, connecting them when you do Y2. This is in dot mode. This is in connected. So let's look at that. X-res equals 8 really gives you a lousy graph. It's like asking it to have extra caffeine. So these are some features. Now, that's not a new feature. But when we set up the next activity, we're going to look at that X-res and see how it will affect future graphs. So I'd like us to go to the next activity, which we call mining for gold.
Can you explain how to do 3D? I cannot get it to work.
Oh, I have given you more on the handout because I, like you, thought these were so fun that I thought you'd want some more delights for your own later. And 3D on the handout has 1 minus 1 over x plus 1. Let me just tell you, that's a great question. If you hold onto this taffy and redeem it later, I got to really do a better job of throwing. I'll help you out with that one. So save that for later, and we'll enjoy it. And we'll over a taffy. But I want to kind of move ahead. What was your question about it? You were trying to get the graph in there? I'm sorry.
Yeah, I was trying to get it to take I instead of X for the set the limits.
Oh, those sequence functions, summation functions. That's interesting, yeah. That's for the extra student after class. OK, great. So there's some more fun on the handout that you can play with the templates. Let's look at mining for gold. So I'm going to second quit and start with a home screen. And I'd like to set mining for gold up for you just to get an idea. A lot of my students are really into The Hobbit right now and dwarves and digging in Minecraft. And so I thought I'd come up with an activity that has some dwarf title to it, but that's about all it has. Because what we have is we're looking at rectangles that are special. And they're so special, we'll call them golden rectangles. So here's just simply a 1 by x rectangle. And there's lots of ways to make golden rectangles, but they all involve a square. So if I were to draw a square and take a square out of this, so that's close to a square. That means that this is 1. And what I'd like to do is make the rectangle that's left have a special property. So here's a rectangle now. We know already that it's 1 in length. Can you tell to your neighbor what is its width? If this is from here to here, x. You weren't needing much time there, x minus 1. Yeah, we just took away 1 from x. So what is special about a golden rectangle is that's the kind of rectangle that I would have when I took a square out of it. I have a remaining rectangle that's the same ratio. They're similar rectangles. The lengths, the sides have the same ratio. So if 1 is to x, then, well, that's the width to the length. Then this is going to be x minus 1. Now we have a neat little equation. Math comes in. But it came from our definition of a golden rectangle would be any rectangle out there that satisfied that. Well, that creates the urge. I feel the urge to cross multiply. So I'll make x times that quantity, and we'll see x squared minus x equal 1. And with our friend, the quadratic formula, we can come up with a value for x. The special value for x, they call that golden ratio. They use a letter called phi. So that's called the golden ratio, and it is the ratio of the the length to the width of the golden rectangle. Let's find it. We can solve it by the quadratic formula, and my way I would do it is I'd have my students do that first. And then I'd like to have them go to the solver, and I want to show you the excitement of the TI-84C now with the solver. So we're going to press Math. And the solver is at the bottom, so all I have to do is just up arrow. There I have been busy already from my past session. But what I want to do is I want to put in 1 over x in one of the boxes and x minus 1 in the other, because if you recall, that's what we're trying to find, the x for which that statement is true. What do you notice different about this solver than the 84 solver. There is more here than we have on the 84. Do you notice, maybe you haven't used it? First of all, you can have math print in it. And second of all, you don't have to set one of them minus the other and find when it's equal to 0. You can just set them equal to. So it's very nice. Now that OK is a soft key. By the way, there's another thing that's really handy. You get a bit of direction from the calculator up here at context help. Enter equation E1 equal E2. And now we hit OK. We're going to press this F5 key. So we have to hit that key. And literally, this has happened to me. I have had a phone call, an emergency from a colleague saying, John, quick, tell me, how do I use the solver? What do I do? I can't get it to solve. I've been pressing every button. And now I won't get those phone calls anymore because all I have right there, select variables, press alpha to solve. And of course, I won't make any money off of my consulting fees for that. But press alpha to solve, so we'll just do that. This was the last x that, last number that was stored into x. So you hit alpha and solve, which is down there. Behold, you have found a number that we wanted that made this equation true. Because the marked solution now shows you it's solved. I think that's just truly a life changer right there. We've got some nice functionality there with the appearance. Well, let's solve it graphically. So we're going to now put that in the y equal. So let's clear these out. And here's an interesting discovery that I learned this week. I've pressed clear once on the calculator, and yet it's still looking the way I had changed it. It's not the way it came out of the box. It's not the default setting. I learned that if I just press clear twice, it goes back to the earlier setting. So just stutter, and you'll be good. And we need, well, we're going to put in 1 over x. And I'm going to put in the stacked fraction 1 over x. Although, if you'll notice, you might kind of find that silly because we already saw that this is very irrational. But nonetheless, I want to put it that way. So when I trace on it on the graph, it'll look nice. And I need x minus 1 in here. Now, there's some more excitement coming when I go to the Format menu. And we'll see. There's, on the handout, you'll notice there's a bit of direction there with the screens. And so we're going to go to Second Format. And we'll see that you've got new features here. This grid line is my favorite feature. The grid line enables me to have that higher resolution to my best advantage. You can change your grid color if you wanted to, or your axis color, just as we did with our y equal color. We're using those spinners. I'm going to leave those as is. But there's one thing I want to change down here. I mentioned that XRes before. Here is an opportunity for me to have another control of that. If you look at the context help, it says XRes equal 1. So what I want to do next is get that XRes. Rather than change it, I'm just going to hit that to off. If you recall, on an 83 calculator, TI-83, when you press the y equals tangent x, it'll graph the tangent, but then it'll make those connection pieces. We call that false asymptotes. Because they're really not an asymptote. It's just a false connection piece. You saw that when I had that other graph up there on x res equal 8. It just didn't look very good. So this keeps, the decision is that we're going to have this on when we get it out of the box, so that if you were graphing an 84, 84s now, if you graph tangent x, they have what we call asymptote begone. It doesn't show anymore when you do the asymptote. So it looks to see, is there an asymptote that could be possibly graphed falsely? I'll prevent that. I'll detect that and keep that from happening. This will speed it up if we don't care about that. If we just press off, we'll just not worry about looking for asymptotes, and it'll change the graph speed. Any questions about that? OK. So now we need a window, and we need to fix our window. If you'll trust me, I'd like to use the window in the handout, which you can see has a benefit to it later. So that's negative 0.6 to 6. And then we have negative 0.1 on the y min to y max equal 4. And I'd like my x res to stay at 1. As I did this, what I'm having is, notice a change in x is showing on there. It also tells a little bit, the delta x is a nice friendly stepping increment on the graph. So now I press graph. And there is my graph of y equals 1 over x and my graph of y equals x minus 1. Find an intersection, please, and let's get that on the window. So we're going to go second, calculate. 5. Are you OK? So if you ran into some trouble, you had 3 things to happen. You have to have your y equal screen look like this, 2 functions. Your window, and the handout on page 3 has that window on there. And then your second format screen has the grid line and detect asymptotes off. So I noticed there was a question. So make sure that everybody's in good shape. Now, have you used the calculate menu before with the intersection? If you have and your neighbor hasn't, you can be a helper right next to them. So we're going to hit second, calculate. We'll arrow down to number 5, intersect. And we'll ask first curve, second curve. And you got what we had earlier. It's beautiful. Now, what is awesome to me is there's my x. I would like to store that on the home screen. So this is important that you have this screen on your calculator to proceed with the rest of the activity. If you don't have that and you need help, feel free to raise your hand. We've got assistants. Medics can come. You need some help. OK, great. So that's important. And next, what we want to do is we would like to pull that off. And what I'd like to show you is what I want to do is I want a golden rectangle to show up on my screen. That's what I want. And I know that I can get one if I shade. Oh, I'm going to use a different color. Here is a golden rectangle. Oop, I get my eraser out. So I have the width of the golden rectangle to be 1. Remember, this is a grid. This is actually a nice window because these are 1 by 1 little squares. And the height is 1. And then the length is going to be this number right here, which you found was the golden ratio. So that's from here to here. And so if I can get this shaded, I'll have a golden rectangle. That's what we want to do, a bona fide golden rectangle. So I've got that on my screen here. So what I would like you to do is second quit so we can get that number onto into a place where we can store it. So I'm going to hit X, and if you hit X and you had that screen, you should have this. Now we're going to store it, and I don't have a number, a variable called phi, but I do have, I'll just use A, and I'll hit the store button and hit alpha A. If you remember, that went through the graph of x minus 1, and so x minus 1, or a minus 1, would also be the y value. So I can just recompute it. And that's the y value that I had on my screen. So those are the two values there. And I'm going to call them A and B. Now I've got A and B. And if I want to think about, remember that 1 over A should be the same thing as A minus 1. So it checked out. That's what I was hoping for, because that's the equation that I needed. So we're at this screen. And what I'd like to do now is draw a vertical line that will be this line right here, x equal phi. I would like that vertical line drawn on my graph screen. So we can do that two ways. And I want to show you how two ways to use the draw menu that can also be part of this colored feature. We can see some new colored enhancements. So we've kind of looked a little bit about stuff that wasn't color. Now here we go bringing the color in. So to get that colored shading, we're going to first got to draw a vertical line. We'll go to the second draw. Oh, stop a moment. Hands off of your calculators. Great. Now, if you are somewhere other than here, you need to first be here at this screen, or it won't work. Now you may touch. OK. So nope, don't go there. You have to be here. I did show that picture, but that was on my document. So apologies. Here is where you want to be. You want to be on the home screen. So to get there, you just hit second quit. So be like Dorothy. Get to home. That'll take you there. We're here already. Now, what we're going to do is we're going to go second draw. And we have vertical. Now, one of the things that will just go smoothly is just if we notice the vertical command. Have you used it before, vertical? OK. Do you have any idea how to type what next comes? Wouldn't it be great if we had catalog help? Just a help, like I don't want to pull out the manual. Here's a wonderful new feature now. Catalog help is just built right in. And you press, when you're on catalog help, which is a separate app on the 84, you press plus. I remember that because it's the 84 plus, right? So just press, oh, you have to be highlighted on it. And press plus. And things now have moved you into a world where you have a little bit of assistance there describing what it is. So you hit alpha A. And then you have a comma. Y alpha A, we want a vertical line, x equal our golden ratio. And next, I'm going to actually ask, we can put a color there. So remember, raise your hand if you need assistance, because we have some helpers. We're going to put a color. I don't know the color numbers by heart, because you've just seen this today, perhaps. So we'll go to the variables area. See right there is the variables. And there's a color menu that shows all the colors. And the words are printed on them in case you have a student who's colorblind. They can just see. I'm going to go with magenta. And if you're really interested in what the line styles are, look at the handout. They tell you that their numbers 1 through 4. And yet that is based on what will happen on the spinner when you get on the spinner. And it looks like we need to paste. We're ready. Watch after you hit the paste button that you also say please. The enter key is the yes please key. And there's our vertical line. Now, it's not, I was going to say exactly. We know it's not exact, but it's as precise as we can get it right on that intersection point. If I had traced it with it on the screen, I wouldn't have gotten that. So now how to shade that? Positive affirmation? Good. Now to shade that, we need to use the shade command. And the truth is, it doesn't matter whether you're coming from the screen. The shade will always paste onto the home screen. But I'm going to go second quit as a good practice anyway, to see that screen was what I had. And now I'm going to hit second draw. And I'm going to use that catalog help again, which really can pay off because what I need is lots of stuff in there that I would never know by heart. Now, when we use the shade command, what's it asking for is a couple of things here. It starts at a lower value. I'm going to go to black here. So the lower function here that I need is 0. So it goes from y equals 0. And the higher one is y equal 1. OK, so I have to put a 0 there and a 1 there for my lower and my upper. And we have a 0 here for my x left. And my x right is that golden ratio, which you call A. We called A. We can call that phi if we wish. So let's get that on the screen. We'll go back to this. We're needing 0 and comma 1. And we need then left. And then we need alpha A. Now there's other choices, pattern, and that other thing there, which, does anyone, so that's all we really would like. If we need the color, though, we have to use the defaults for those other things. Does anyone know what that, this word is, how to pronounce it? Anyone who's not from TI? That was it? Patres. See, I, from being Catholic, would look at that and say, oh, nomine patres, you know, and I think that's the father variable. I was really messed up. So, excellent. You guys nailed it right off the bat. See how my, there we go. It's raining. It's like Easter, only we're in Lent. All right. So, pattern res, pat res. So let's use 1s for each of them. Because if you really want to know what they are, what choices, you can play with them on, by looking on the handout for the curious. So I'll just put a 1 in there. Because I do need to put those in there if I want to put in a color. And you remember where to find the color? Variables. And I think pink would match the vertical line. We can just type the 4 key, or we can hit the, and for politeness, we'll close the parentheses. Now we need to paste it by hitting the soft F4 key, or the trace key. And don't forget, it only works if you say please, or hitting the enter key. I tell you, there it is. It's beautiful. There is a golden rectangle. You couldn't have drawn it. It is as pure as you can get. And It drew this because we asked it to go from y equals 0 to y equals 1, and so it went all the way. So that's how it did that. And you've got it. Now, remember, this is called mining for gold. You can get more golden rectangles if we actually have the extra, put a square there. So here's my marker. So I'm going to put a square. What I'd like to do is put a square right here. And if I have a real golden rectangle, that means that that's a golden rectangle, because you said that's what it does, right? So just like Thor and Oakenshield, I can mine for some more golden rectangles once I found the vein of golden rectangles. And let's put that square there. And this is where I can show you a little bit more about the draw menu interactively. And it's kind of fun. So look what happens here. We're going to go to need to be on this screen. So if you haven't pressed graph, you need to be pressed graph so that you see this screen. Because we're going from this screen to the draw menu, and that makes a difference how the draw menu behaves. So we'll go now second draw, and we want line. This will help you see also a little bit about that graph style. So there's some fun with this, and also you're kind of learning a little bit about all the features. So we hit number 2, or line, and there's this soft style key, which will bring up that spinner. Let's take a look at that. When we hit that style key, you can make this to any color you wish, and you can change your line style too. I'm going to go with light blue, which is on my handout, although my handout's in black and white, so you'd never know that unless I told you. But if you go on the web, you'll see my handout will be light blue. Don't forget, you have to hit OK after you get down there, or nothing will stay. And to hit OK, we have to hit Enter. Now, what's helpful to me is that window was designed not on accident, but so that when I use the draw menu, I can get this to land right where I need it to on friendly numbers. So I'd like to get that. The draw menu didn't draw a line yet because I have just first positioned my point to one place. I'm going to draw this square on my graph screen. So to start, I hit Enter to begin drawing the line. And I can go either way. I'll go up. And you notice the line is beginning to draw. And I'll go up to 0, 1. I'm going to make that a little larger so it can be seen better. And to stop it, I hit Enter. And I've drawn the line. But wait, I need 4 sides. So let's just redraw by hitting Enter again. Hitting Enter will start drawing. And go to your corner 1, 1. And hit Enter to stop. And what's neat about kind of activities like this is once you do the skill once, you get 3 more times to practice. And then I'm going to hit Enter lastly to close my square. And I have done I've made a square, and I've made another golden rectangle, which I can see what its dimensions are. It's of height 1, and its length, as you saw, its length is 1, and its width is phi minus 1. So there's that. Now, the rest of the activity repeats these commands, really doesn't bring anything new in it. So I would like to kind of do what Julia Child does. Do you remember her? She'd have the recipe, and then she'd say, now I'm going to pull the roast out of the oven, you know, and show you at the end. So I have a little program to show you the final product. And so if we go here, you can see, you don't have this on your machine, but I'm going to draw this is just replaying what we did. There's my magenta, and there's my square. So there's a golden ratio. I can make another square to make that a golden rectangle. Here's a golden rectangle by adding squares. I can add squares now to make this big golden rectangle. And so I see all these golden rectangles on this screen in color, and I could never see this on a monochrome screen. And yet by making them, now I understand where they came from, right? So, and have you heard of the golden spiral? So it starts, wouldn't it be wonderful if we could just have a golden spiral on this? Well, there's one. So we get a connection between all of these squares, circles going from the diagonal. And we can see these applications in art through the Mona Lisa. You'll see a golden spiral in her. You can Google this in other ways. And so you've got the Pantheon, all these wonderful places where you can see that. But the mathematics as well can be neat, because if you look at the ratio of these sides, the handout asks you to look at the ratios of those sides and then solve. You don't have to solve the equation again, but you can just make it evident that that's a golden rectangle by showing that equation's equivalent to what we had up here. We had this equation right here. And that is true for all of the ratios of the side lengths. One more thing about this that's so exciting to me is I can measure these widths and lengths, and I look at that and put them in a column. There's a pattern to it. And if you smell the aroma of Fibonacci, he's in there. So that's investigation 2, bringing some neat color as well as some mathematics out of the Common Core. OK, let's take a breath. Oh, I thought it was cool, too. Thanks. Very appreciative. And we're going to look at a water fountain activity. So with color, you not only get abilities to really make beautiful graphs and displays, but you can bring in the whole real world into your calculator and into your classroom in ways that you couldn't do with the 84. So investigation 3, we're going to go to the drinking fountain where there sits mathematics waiting for us to explore. So I have on my handout one way to do it, and then at the very end I suggest, well, you could do it another way. What I'd like to do is we're going to show you how you can get that image on your calculator and then model it. And what I'd like is to have you have a conversation with another person. Maybe one of you picks one approach with one window. The other person chooses a different model, a different set of axes location. And we'll see how the results compare. So you get to explore as well as actually say if there's a discovery at the end. It's a treat. So how do we get that going? We need to, let's go first of all to the home screen. It's a nice place to launch off of. So we'll go to second quit. And what we'll want is I'm going to do another Julia Child sort of thing here and put that on there. But your very first thing you'll need is the window that is either of these. They're both in the handout, but this might make it a little easier. So you guys get to decide right now who is partner A or partner B. In fact, in the handout, I used Lauren here and Warren there. I was really original. So one of you could be Lauren and the other could be Warren. And pick the right window. Once you've got your window, we're going to get that in there by going to the Format menu. The Format menu has, we could use a grid line. I'll let you decide if you want to use it or not. But it has a background menu there, a spinner. Yours is starting at off. Okay, so you'll start your background at off, and just clicking on it, right arrowing is what I need to do. You'll scroll through what will be in the calculator when you get it out of the box. These 5 images are already built in. You can change them and overwrite them if you want. You can pull them off of your calculator and put different ones on. You have 10 storage spots on your calculator. So you're not stuck with these 5. However, they were picked for good reason. They're very fertile with mathematics. So we're going to use this. And while all the world sees perhaps the water fountain, you and I see the parabola. So that's what we're going to put in there. So all we have to do is just leave that by hitting a down arrow or an up arrow, and you've selected it. You can tell you've done so because there's image 4 selected. And if you press graph after your window, you may have some stuff in your calculator that you may clear. You may want to clear your y equals screen. And as you can see, I've picked to be Lauren. And I now need to go to a place where I can actually drop points on this graph. And that is in the area where we model, and that's the stat menu. So it makes logical sense where to find what I'm going to do. It's going to be under stat, right arrow to calc. And it's at the very bottom, so a sneaky way is just to use the up arrow to get to the top. Or use the up arrow to get to the bottom. And that's what we want. Quick plot and fit equation. Watch what happens with this. We'll hit enter, and we get a couple of choices. So the very first choice, it says drop points, and we get a little bit of help sometimes up there at the status bar. But we got a style button right here. Let's press F5, or the graph button. And you can change what color those points will be dropped, as well as the color of the model. I'm going to go with navy, but you can pick whatever you wish. We'll go down to hit OK. And if you look up at the screen, you'll notice that what will happen is my points have changed color to navy from blue. Not hard, not easy to see that big change, but I'm going to drop the points on this window. It made it convenient for me to be able to land right on 0, 0. So I've made the axes choose so that I can hit 0, 0. And what do you think you need to do to drop a point? Hit enter. Say please. Yeah. And behold, you have plopped. Now, another possibility, if life were an integer world, which it mostly is in beginning applications, we'll hit -6, 0, but it doesn't have to be integer, right? We can do anything we want. But picking that might make this parabola have a nicer equation. So I have an axis choice. Let's next just simply drop points on places where we will find the path. And I hear the wow already. Yeah, you can tell who's gotten done already. Once I picked a suitable number, a parabola certainly won't like just if you picked 1 point or 2. You better have 3 at least. And I would do a lot more than that just because 3 seems awfully cocky. And now I will just hit the graph button to fit equation. Well, you can see all in the steps in the handout that will walk you through if you miss your place. But I want to go to the choice that I would fit best. So we'll go to number 3 or hit enter by selecting that. And look at that. Now, we're not done yet. There's more to be had, because it tells us the regression equation, but you don't necessarily have to use it. You might have said, no, I don't like that. I'll do something else. So you may now commit, if you wish, by going to the store soft key. And if you leave from here, it's like, well, that was done in a fine moment, signifying nothing, right? But, well, not quite. Secret to be had. A list is hiding now in your list menu that has QPX and QPY, that has all of those points in it, should you change your mind after you leave this screen. So they're in there, but they get overwritten like X does every time you play this. So let's go to store. And we picked a color. This is good news. Once I've stored it, I can change my color choice to anything I want. I like the defaults there, so I'll go down to hit yes or for OK, and it will replay the graph and do what it did, do what I asked it to do. It will have y equal contain this, which, by the way, looks a lot different than had you stick to quadratic regression on it. It's a little nicer in terms of numbers of digits. And it has the plot on. And in your stat editor, look at this. This is worth noting. I've got some other stuff in there, but no color for a reason. Non-color is as useful pedagogically as color is. Nothing has said to the calculator that these are all dates to the prom or something like that. We don't need to, it doesn't know that unless we change it. And so if you want to change your color, we know how to change y equal. If you go to second stat plot and hit enter, there it put it in. And that's how you can decide, well, L1 and L2, we married them together, and we'll fiddle with our color here if you'd like to change it. So you can change it here, or at the beginning with the style key. And remember, I changed just the plot, not the equation. So if I hit trace, I can see, oh, there's the plot, yes, and here's the equation. Did you have a chance that someone did a different one next to you? So look at that. We've got two choices. I'm not sure how you can see the light blue really well, but if I look at these two choices, what's going on with my my a? So if these are y equal a, x squared plus bx, and c is pretty close to 0, they're pretty close to the same. Not a surprise. We can ask now why to the students. Well, what is that a? But if I think about my a, that's if I went 1 unit over from the vertex left to right, a is the distance I go down to hit the parabola. So that a would be the same. They're the same shape. And what is the b? So here's b. Kind of hard to see them now, but one is 2.4 negative, and this is positive 2.4. And that's no accident. So that's the slope right here of the tangent line. I'm having a little trouble with my pen, but now I can really see it. So negative 2.4 is the slope of this line, tangent to the graph at the origin, and positive. So we can see kind of what b does and why they're different, and we get this now. We've got that. So it's not just about maybe let's put a graph on and model it, but we also say now the real world out there that exists, we can mathematize it. Comments, thoughts on this? Where you can see? OK. I didn't show you that on my format menu on my calculator, I can also put other things on there. The starfish, we can put that on. But I put the Ferris wheel on that I pulled off of Wikipedia Commons. So you can pick anything off of Wikipedia Commons and fiddle with it and adjust it. But I just grabbed it as it is. there's on the very last page of the handout how you can get your own stuff on there. You'll use TI Connect. And that's going to be out. A lot of people ask, when's that coming? We're looking at late April. If you're not a Mac user. Mac users, it's already posted. It's before the calculator's out. So there. And what can you do with that? Just for fun, I want to show you that I put that Ferris wheel on it, and then now I'm riding the London Eye. Literally, I've got a movie on my calculator. Now, you don't have this on yours because I didn't put it on there. But I can see on that handout on the how to get the calculator image on. I also put a sample equation where now students have to stretch the circle to use it parametrically and shift it left and right. And so they have to, again, relocate it so that they get there. And typically, my students want to do that. So I've now made a new way for them to get to the mathematics that they need by giving them this carrot and saying, it's a Jedi mind trick. You want to, to put that circle up there. And I like this just to share with you why I have that extra line, that this is actually you can ride this as well. And say, well, this is what the graph did. If we're looking at the speed of this, and it really is kind of neat in calculus because it slows down. Oh, I went to the other one. Got to get over here. It slows down here and speeds up there. So if you're going to ever regurgitate because you're sick on Ferris wheels, it's likely here. That you're going to do that because that's really the fastest thing. And we can see that in the rate of change. Fun mathematics. So, that's kind of using images. And now, let's use one more image. I'd like you to go to the format screen, and I'd like you to go to image 5, which is already on your calculator. A little starfish right there. So this is investigation for making baby starfish. Well, actually, we make a lot of starfish. It's springtime. OK, so we have starfish, and that's image 5. And the other settings, if you want to keep them not touch them, that's OK. The border color. I want a nice blue. I think that's the one that, because we're in the deep blue sea and the starfish, so I like border 3. This is a nice one. Let's second quit. And let's see if I can get that screen showing for you, so in case there we go. Now, second quit. I clear all of this. What I'd like to do is just hit zoom. And my favorite now is zoom decimal. Because it really, especially with the grid, I don't have the grid on. Oh, and I have a remnant of some previous work. So, well, what do you think I should do to fix this? Yeah, go to second stat plot. And there it is. Or I can just hit the y equals button. And oh, there's my Ferris wheel unveiled. Sorry, we don't need that. OK. So now if I press graph, things look good. Well, we're going to use quick plot and fit one more time. I know you've used it once. Having it one more time, you get a chance to feel another sense of its power. So we're going to go to Stat. We'll go arrow to Calc. And we'll use the bottom choice, quick plot and fit EQ. And apparently, I have better fix something. It is, yeah, a couple of stuff still not cleaned out there. You're probably okay, but I ran my Ferris wheel, and so I'm going to go back to the function mode. Sorry about that. I was graphing the London Ferris wheel on my starfish and underwater. Only on TI calculators can I do that, I say. Now we have nothing going on. Oh, he's down there. Isn't that great? You get practice turning things off. OK. Now, did you notice, and I had some help in the back, that this busy signal really tells me you get better at looking up here at what's going on if things go bump in the night. And that busy signal was saying, you're doing something. And so that was something that I wasn't looking at. And you learn, keep looking there. OK. So now we can go to where we need to be. We're going to go to stat. We don't hit second, just stat. And then calc, right arrow. And then up arrow. And you're probably there already. Do you want to change the color? I do. So I'm going to use graph. And I'm going to go to light blue because there is a light blue boundary on my little starfish that I want to enhance. No need for Botox. We're going to give the starfish a bluer boundary. Hit enter once you've gotten the line. And we're going to drop the points. Now, what I'd like to do is I'd like to get line segments connected to make that boundary. So I'm thinking line segments, but I'm not going to get the line segments. I'm just going to get the endpoints of the line segments right now. We'll get the line segments in a minute. So I like to position this on a spot there. I'll hit enter. And you get a little help from the handout there on some of the screens. But I'm just going to make a line segment that will cover all of the points. Now, I'm not sure how I might use this in the science classroom, but there is definitely some mathematics behind this 5-pointed star. And it's also neat that if you goof up, there is a forgiveness factor later. So don't worry about perfection. It always gets me in trouble. So once you've got the hang of it, you kind of just roll around the starfish. And I haven't yet told you what Common Core standards this is going to fit yet. So that's a surprise yet to come. And I'm being a little bit more anal, precise about this. So I may wish to just be a little more wide in my points. I really feel so, the need for this to look just as beautiful as if my doctor were performing cosmetic surgery on me. I would want him not to say, oh, hurry up, when's the next flight? Just. And when you've got your starfish, you can just change, or you're finished. One of the tips I have in the handout is that it'd be awfully nice if your start point matched your end point. If it doesn't, when you're done, we can fix it. We can fix everything. We have an easy button up here. So, OK. This is probably easier for you on your device than on me with my Smart View, because I'm busy there. But what I would like to share with you is where it meets the Common Core standards is that you've got a shape on here now that we can use to transform using the coordinates that are being stored right now. Who remembers where these coordinates are stored? Yep, QPX and QPY. So I've done what I think is sufficient. I've done more probably than I should have. So I'm ready. Do I need to fit an equation through this? Not really. You know, I don't really want a line through there. I could if I wanted to, but I'm just going to leave now because it's already in QPX and QPY, which is different than the handout says, because the handout I was thinking, oh, I should fit an equation to get through it. So I'm going to just second quit, relax, it's there, okay? In fact, when we go to second list, there she is, QPX and QPY, right there, sitting on the screen. And if we want to see what they are, well, we can go into the list editor if we want to. I'm going to do that. I'm going to go edit. And there is some old stuff that I don't need. I'm going to clean that out. I could use the named lists if I want to, or I could store them. In fact, I could, I don't know, second insert. We could just do that. And hit second list 7. I know that was fast, what I just did, but I wanted just to show you can display what's in there. That's your data. And then I can hit right arrow and second insert, and now second list 8 with my list number QPY. I can put that in. There they are. There they are. And the very first one was 1.80. If I go to the very top, I can see that I don't have 1.80 as my very end. Oh, blast. But I can just type it in there. And so I can put 1.8, enter. But I better have a pair with it, otherwise somebody's going to be jealous. So I better get that in there. Now, that's not really a big deal if you don't want to do that. It's OK if you don't match it. But if you're really, like my doctor wanting precision, there it is. Now, what I want to do is go to my stat plot. So I'll go to stat plot by pressing stat plot. I'll actually press second stat plot, and there we have it. And I'll go into any one of my favorite plots. I'll pick plot 1. We have to turn it on. But you know what I really want? I wanted those connected. So I'm going to not have a scatter plot. I'm going to have XY line. And depending on the level of your students, if you wanted to store them into L1 and L2, then use that. You're done. Now we didn't. We'd have to hit second QPX here to get that, and second QPY. Something's going to be very nice, though, here. I want to share with you something that's an improvement. So we're going to hit second list, and we need that QPX. And we could hit second list and paste in QPY. Now, if I were, sometimes I like to change windows while I'm in this area. If I were to just press the zoom button on the 84, I would be hitting the alpha, it would be an alpha lock, and I would be hitting the format menu, and I'd get to the shortcut. That has been now revised in a nice way so that I don't have that. It's got, kind of in the way of what most people do. And so here's where we can change the color. I like my light blue. So I'm ready to roll. I just hit graph, and those points now Oh, but I may wish to do better cosmetic surgery, so we'll just hit second plot and fix that dot. I got to go back to that. A nice dot would be good. And then hit enter. And now graph. And there it is. And what's also nice is just that you can change these with the, we have just 1 minute left. You can change your oh, I did store these into L1 and L2. You can change these on the handout where you can make the graph modify this, where I can stretch them and shrink them. And I think at the very end we have that with y equal, and I think that might be in there. It may not. Yep, okay, they're in there. And I'm going to highlight this. And so now I can broaden it or make it shrink. I've made little starfish and big starfish. And I have empowered myself with what is normal beautiful to make it even more mathematically beautiful. And if you wanted to change your L1 by growing it or doubling your L1 but not doubling your L2, or you can see, oh, now how does that change? All this exploration can happen. You've been a great group, and there's so much more on this calculator, so I hope you go to some more sessions or some summer institutes and to the website. On the cover is my web address where you can get the handout and any programs and other fun stuff that I'm developing. So I hope to see you there.